here we go. The Zoom session is being brought to you by the fractal outer inverse bullseye. Okay, yeah, so today we'll be going over cosine and the sine relation, specifically combining them. We have a combination of cosine and sine. A cosine x plus b sine x will turn out to equal a constant times cosine of x minus another constant. And here's the reasoning. You pull out a factor root a squared plus b squared, and you get a over root a squared plus b squared cos x plus b over root a squared plus b squared sine x. And if you look at this right angle triangle, the sides a, b, and c, then c is square root of a squared plus b squared, as you might expect. And this angle theta equals arctangent of b over a. So cos a is a over root a squared plus b squared, that's this. And sine theta is b over root a squared plus b squared, that's this. So we have root a squared plus b squared times cos theta cos x plus sine theta sine x. And cosine plus sine is cosine of a difference, x minus theta times root a squared plus b squared. So root a squared plus b squared, cosine of x minus arctan b over a. That's the identity. So all right, it's a simple matter of this. Cos x plus sine x, a and b are 1. So root a squared plus b squared is root 2. Arctangent of b over a is 45 degrees. So it'll be 1 root 2 cosine of x minus 45 degrees. Here we have a is root 3, b is 1, and we work out this and this accordingly. Here's 2 and 1 sine x. Here's 3 and 4, so 3 cos x plus 4 sine x. Here, the root a squared plus b squared is root of 9 plus 16 is root of 25, which is 5. But arctangent of 4/3, we don't have an exact value. It would be an approximate. You leave it either as arctangent of 4/3 or write it as, well, what will arctangent of 4/3 be? Arctangent of 4/3, well, depending on degrees or radians, it's 53.13 degrees. And you can write how many radians is that? About 0.927 radians, whatever. And for number 3, cos theta, 2 cos x plus 1 sine x. A is 2, b is 1, root 2 squared plus 1 squared, cosine of x minus arctangent of 1/2. Okay, I'll leave this to you. It's a simple one. All right. Could go on, talk about inverse trig. I think I'll save that for next time. So I'll call this done for today. Excuse me, cat. Cat's here where you can't see him. He's sitting in the most inconvenient spot because he's a cat. There he is. All right, let's get out of the way. There we go. Stop share if I can see it. Cat, there. Okay. Well, well, all right. So that's what we did. Let me Apollo, etc. Yeah, Brenda, as ever, since we're over the edge of the book, I spent the last few minutes going over one of the extra credit sets, a cos x plus b sine x, simplifying that. Okay. Well, all right. I think we're done for now. Unless you have questions, comments, suggestions, requests. None. Okay. Motion to adjourn. Is it seconded?
It is seconded. Thank you very much.
Seconded. Okay, great. I'll be here. What it was my office hour Wednesdays, and of course I'll also be here on Wednesday and so on.
Thank you.
All right.
Thank you.
Bye. Thank you.
Thank you.